Hi, in this example I will show how to use the UML Checker toolset for the ATM example that is presented in one of our papers. So we have already the files in place, and I will show just the usage of the toolset. So we have the Java project created in Eclipse. It was created as an Aspect.J project. It was created like this as an Aspect.J project. We created the source files. So in this example, it's just a simple ATM simulation. So we have bank accounts, and we can perform some operations on bank accounts, like withdrawing money. And when we do withdraw money, there is a movement that is created. So we have already files in place. The project is already configured. So we already configured the build path. We can take a look. So if we configure build path, we see we already have our runtime library. I can just show how to add it to the project. So I'll just remove. So you have to add our runtime library, the trace-utils library, to the project. So in this case, I have it available here, the trace-utils.jar file. I add it to the path. The other thing you have to choose between compile time weaving and build time just in time weaving. So to configure compile time weaving, you have to go to the properties and to the Aspect.J build and the Aspect.J path. So for compile time weaving, you have also to add here the same library. So our runtime library that has the aspects for tracing defined. So we add it to the project, and we recompile the project. Okay, it was already compiled, so everything is okay. Now we have also a model in same project, which I'll show. So we have already a model. As you can see, the model has a dynamic or behavioral part and structural part. In structural part, we have the classes defined within the packages. So it's important to have defined the classes that are to be used in the behavioral model, so that we have the packages properly defined. And now in this case, in the behavioral model, we have inside the dynamic view, we have a package that we called ATM test, and then another folder, ATM test, where we have the sequence diagram. So this sequence diagram is a very simple example of modeling behavior. So the diagram illustrates how the API, this ATM simulator can be used by a client application. So in this example, the actor represents a client application. It shows how to use this ATM. So a client application can create an account, an instance of class account with some initial balance. Then it can, in this example, request to withdraw some amount of money, and two things can happen when you withdraw money. So if the amount you want to withdraw is less or equal to the balance, so you should return an OK message as return from the withdraw method. Otherwise, you expect some error message. Okay. So in this example, so the balance, so the initial balance and the amount you want to withdraw are parameters. So this is a parameterized sequence diagram, and for testing purposes, we define a node where we provide two combinations of values for these parameters. In first case, so the initial balance is less than the amount we want to withdraw, so what we expect is that the test will fail, and in second case we expect the test to pass. In this sequence diagram, besides we explained the usage of this API. It's a very simple example, but we can also explain how it works internally. So for example, when you call the withdraw method, what happens is that this method has to do two things. It has to update the balance, the current balance, so set a new value for the balance, subtracting the amount from the current balance, and at the same time it has to create an object that represents the movement that was performed, in this case withdrawal. So these two things have to be done by, we use a par combined fragment, so can be done by any order. So in this example we have, okay, we can, this model says that this movement can be created in two ways. So it's an alternative without any conditions. So the implementation can create this object in two different ways. So this is sequence diagram. In fact, this diagram is already painted because it was previously executed with our tool. So we have the source code and we have a behavioral model that illustrates how this program is expected to work. So to run the tool, so we have, if we click on one of this dynamic view, and we have the test generator add-in, and inside, so we just move down. So again, so if we select, we have the add-in and we have the test generator. We have some preferences that were already defined. Just opening these preferences. So as you can see, so in preferences we have general preferences that apply to all projects with our tool, and then you have project specific preferences. You have to select the weaving mode. In this case we are going to use compile time weaving, and location of the source files. So usually you should have a project, a folder for a project, and then the source code should be in this source folder. So this is already set. So we are ready to execute plugin. So now we will execute the add-in and select first option, generate and execute tests, checking coverage, and we execute. Okay, so it will take a few seconds. It is generating test code in some places. We have our project, and afterwards it will execute those tests and provide a result. So currently we are presenting a kind of final messages to explain what happened. So it basically, it is not an important thing, it's just a debugging message, and basically it says that one test passed and another failed, and we are also presenting for performance measurements some execution times, so in total it took about 13 seconds. But what's important is that the results of test execution are presented in the diagram. So what we get is that so the diagram is painted, is colored, and what you see is that the first test case, so the first combination of parameters failed and the other passed, and we can see that so the message that failed is painted in red, and in the note we have the error message. Just so that everything works well, I just remove this information and reset some coloring to make sure that really this is not a fake demo, so it is really produced by the tool. So we just remove all the colors and we'll execute again the plugin. Okay, remove the colors for lettering. Okay, so select the black color for everything. Okay, it is not so easy to change the colors. Okay, reset everything. Okay, everything is ready. Okay, now we save changes and we are going to execute again our plugin. It's running again. Okay, now we have results. So as you see, so it was painted, and now we have this. So the message basically says, so we have an error here that expected, according to this diagram, the expectation was some string, and in the implementation provide a different string. So if we just change this and run again, okay, just select again our plugin, execute again. Okay, it's executing again. Now everything is okay and it passed. Okay, are going just to show the same thing. So just reset this. Okay. And just generate the code again. We have the same error as before. Okay. We can generate and execute tests within this modeling environment. The test code that is generated by the tool can also be used without modeling environment. So after generating tests, we can use them inside the development environment. So in this case, the test code was generated in this folder. We can open it. We can check the date. So this was generated at this time, just now. Okay, and we have the test code that was generated for this example, and we can run it here. So we can run the generic test. So we have the same information. So in this case, inside JUnit you have this the error. So we have this error. We can check. Okay, so we can check where the error occurred. Okay. Okay, it was in this the code test code that was generated. We see here things. Okay, if we change the code, now this message is failed. Execute again. No test passed. So you can use this test code here. Okay, so it's a simple example to illustrate the usage of the toolset.